Hi everyone. This is a multimodal PSO approach to image segmentation by Taymaz Rahkar Farshi, John H. Drake, and Ender Özcan from the University of Nottingham. Let's begin. So, what's the big idea? This paper tackles a key challenge in image processing, splitting color images into meaningful regions, like separating a sky from a tree. Traditionally, you'd need to guess how many regions to look for, but this method uses something called multimodal particle swarm optimization, or PSO, to automatically find the number of clusters and their locations in a 3D color histogram. No more manual guesswork. This is a game changer for making image analysis faster and more accurate, and it's perfect for applications like medical imaging or photo editing. How does it work? First, the method smooths a 3D histogram of the image's RGB colors using a Gaussian filter to reduce noise. Then, it applies multimodal PSO, a smart algorithm inspired by how particles move, to locate the peaks in this histogram, which represent different clusters. Finally, each pixel is assigned to the closest cluster based on its color distance. The paper test is on the famous Lena image and other benchmarks, showing it's effective. Pixels are assigned using Euclidean distance, the square root of squared differences in RGB values between the KTH peak and each pixel, ensuring accurate clustering. What came before? Earlier methods like K-means and C-means clustering required you to set the number of clusters manually, which was tricky. Thresholding techniques, often used for gray images, were fast but struggled with colors. Some recent hybrid approaches, like combining fuzzy C-means with thresholding, tried to improve this, but they still needed user input. This paper builds on those ideas by automating the process, making it a step forward in color image segmentation. What kind of data does this use? The method works with color images based on RGB values. Think of photos like the classic Lena image or images from the Barclay segmentation dataset, which has 20 diverse pictures. These images vary in complexity, with different colors and textures, making them perfect for testing how well the algorithm handles real-world challenges. How is it tested? The researchers use quantitative metrics like F, and Q to measure segmentation quality, comparing it to methods like fuzzy C-means and SFFCM. They also do visual checks on images like Lena, ensuring edges stay sharp. The results show 3DHP is fast and accurate, especially since it doesn't depend on image size. Pretty cool, right? Let's see the results. Here's the original Lena image, next to its segmented version using 3DHP. You can see how it neatly divides the face, hair, and background into distinct regions. This visual proof shows the method's power, and it's tested on many images like this from the Barclay dataset. This automation boosts fields like healthcare and AI. Find the paper via the DOI and URL. Questions? Ask your professors. Thanks for watching.